Hi guys, I hope you are all doing well. Let's see today's question. So today's question, we are taking this up from the topic of definite integrals. And if I talk about the question that is given to us here from this topic, the question tells us that let the limit alpha to log 4 to the base e expression is given to us as dx over square root of e raised to x minus 1 is equals to pi over 6. The question is asking me then e raised to alpha and e raised to minus alpha are roots of which quadratic equation. And if I talk about the answer choices that we have here, the options are 2x square minus 5x plus 2 equals 0, b x square minus 2x minus 8 equals 0. C, I have 2x square minus 5x minus 2 equals 0. And D answer choice we have is x square plus 2x minus 8 equals 0. So we need to figure out which one of the answer choices is the correct answer for this question that is given to us here. Let's see how to solve this question further. So I have the integral of the limits alpha to log 4 to the base e dx over square root of e raised to x minus 1 equals pi over 6. So from here, what I can do is I can just put square root of e raised to x minus 1. Let's say I put that as t. So if I square both the sides, I get ex minus 1 equals t squared. So e raised to x becomes t squared plus 1. Now once I get e raised to x as t squared plus 1, if I take the differentiation of this, I get e raised to x dx is 2t dt. So I get this idea. Now here if I see, I just want dx in terms of t. So I can write dx as 2t over e raised to x dt. But since I want to convert this also in terms of t, I can just write e raised to x as t square plus 1. So that gives me 2t dt divided by t square plus 1. So I get dx is 2t over t square plus 1 dt. So that is the entire thing we have here. If I substitute that here, the limits also will change accordingly because instead of x now you're putting t. So let's say this new limits would be a or b. So we'll keep it as a or b, and then when we resubstitute into the terms of x, we'll again put this limits alpha and log 4 to the base e. So let's use that. So I get integral of a to b, whatever it is, and this becomes dt. Sorry, 2t over t square plus 1 dt and divided by square root of e raised to x minus 1, which is basically t. So this entire thing is t. T and t cancels. So you get integral 2 out, limits of a to b 1 over t square plus 1 dt. And 1 over t square plus 1 basically becomes tan inverse of t. The limits go from a to b. So that is the idea that we have here. Now if I resubstitute this, so 2 tan inverse of, I get from here, instead of t, I can substitute that as root of e raised to x minus 1. So root of e raised to x minus 1, a to b. Now when I have a to b, a is basically alpha, b is log 4 to the base e. So now if I just substitute the limits of a and b, I get 2 tan inverse of square root of e raised to log 4 to the base e minus 1 minus tan inverse of square root of e raised to alpha minus 1. So we get this entire thing, and if I further try to solve it, I get this is tan inverse of square root of e raised to log 4 to the base e, which is basically 4 minus 1, minus tan inverse of square root of e raised to alpha minus 1. So we have this entire thing with us. Now further, if I try to solve this, I get this as 2 tan inverse of root 3 minus tan inverse of root of e raised to alpha minus 1. So once I have this entire thing, that basically becomes my answer for the integral that is given to us, and that is given to us as basically equals pi over 6. So this entire thing is pi over 6. So I get pi over 12 is equals to tan inverse of root 3 minus tan inverse of root of alpha e raised to alpha minus 1. Now tan inverse of root 3 happens at 60 degrees, or I can say pi over 3 radians. So I can write this as pi over 12 equals pi over 3 minus tan inverse of square root of e raised to alpha minus 1. So I can just take this on the other side. So it basically becomes tan inverse of root of e raised to alpha minus 1 equals pi over 3 minus pi over 12. Multiplying both sides with 4, I get 4 pi minus pi, 3 pi over 12, which is pi over 4. So I get tan inverse of root of e raised to alpha minus 1 equals pi over 4. So square root of e raised to alpha minus 1 equals tan pi over 4. And tan 45, it's basically 1. So I get square root of e raised to alpha minus 1 equals 1. That gives me e raised to alpha minus 1 equals 1 square. E raised to alpha equals 1 plus 1, which is 2. So I get e raised to alpha as 2. And if I find e raised to minus alpha, it is 1 over e raised to alpha. So it basically becomes 1 over 2. Now the question tells me that 2 and 1 over 2 are nothing but your roots of a quadratic equation. So if they are the roots of the quadratic equation, let's say this is alpha and this is beta. So if I have alpha and beta, my quadratic equation is given by x square minus sum of the roots into x plus product of the roots equals 0. So I get that as x square minus alpha plus beta x, alpha into beta equals 0. So if I just put my values of alpha and beta, I get 2.5. So x square minus 2 plus half x plus 2 into half equals 0. So I get from here x square minus 2 plus half is 5 over 2. 2 into half is 1. So I get this as 1 equals 0. So if I multiply everything with 2 here, I get 2x square minus 5x plus 2 over 2 equals 0. So if I take 2 on the other side, I get 2x square minus 5x plus 2 equals 0. So this becomes my quadratic equation, and if I see the answer choice that it matches with, it is option A. So A becomes the correct answer for this question that is given to us here. I hope you have understood how to solve this type of questions, which deals with the ideas of using the definite integral properties. So I have to just use the idea of substitution and put square root of e raised to x minus 1 equals to t. And when I solve that and resubstitute in terms of x again, I got this expression that was equated to pi over 6, and solving that I got e raised to alpha as 2 and e raised to minus alpha as 1 over 2. Then I just form the quadratic equation, which basically matches with answer choice A. So A becomes the correct answer for the question that is given to us here. I hope you have understood how to solve this. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions that we are solving. Thank you.